So the next session is just building further on what I've showed. So I will use concepts to send data to the cloud, but now I'll try to do something meaningful with it. Yeah, I think I've shown this one. So getting back, because I think this is important. So we collected all that data in the previous one. Now we will do some analytics on top of that. So this is a stream of events that we will get. Scenarios, think about traffic, every car that passes. Think about your website, who every time a user clicks something on a big website could be important to see, whoa, this page is trending, or oh, something happening. You could read on Twitter, on your own company, what's the sentiment for my, for my brand, for example. A lot of things you can do, and that's not always easy to write it in a traditional way, like select average star from difficult. So you need to keep track of all that data. A lot of times you get a lot of data into your cloud, but you don't need to store that data, all of that. Think about customers, you talk with them, your devices, how many times do you want to send data? I want to have it very accurate, every minute I will send. If you then start calculating thousands of temperature sensors every time, every minute, if you then calculate how long or the amount of data that you would have to store long term, it can become pretty expensive. Because this is where the cost is, the long-term storage. What it could be beneficial is that you say, okay, we want to have that granularity of 1 minute, but maybe we will still aggregate per hour, for example. So you will have a good average for that hour, but we will aggregate and we will only store 1 per hour. So you can reduce a lot of the amount of events, reduce it to your long-term storage. That's something that often happens with Stream Analytics as well. And then a lot of times, things you cannot just do on static data. The average speed at this moment, yeah, how do you measure that? So that's all done on a stream of events. Correlating data, all of that will be done by Stream Analytics. And that's what I will be talking about here. So the scenarios that they talk about, financial transactions, the connected car is a very nice one. Clickstream, so who's clicking where on my website. Of course, that won't be that important for our website yet, but there might be a lot of other websites that have the need for that. Smart grid, so energy, getting data, seeing that the quality of the air and so on goes better or something. Customer scenarios, fraud protection, all of these things can happen. Now, what's the intention? What's the aim of real-time analytics, streaming analytics? To have, again, millions of events per second, but they will use event hubs for that. A continuous stream of data, so you can just pump data all the way through that. And think about if had someone played with Stream Insider in the past, SQL, at least 2 of you. There we had the concept of standing queries. So there was streams of data, and you were doing, it was link syntax. So it was pretty complex to get started. And you had to write link queries between all those streams. It's the same concept. So you have standing queries on that stream of data, but the query syntax will be much easier because it's SQL based. So it will look like very you're able to correlate events, so correlate streams, correlate reference data. Fast time to value. It's a bit of a marketing slide, but it's true. You can very easily, once you have that data in your event hub, you can very easily start building things there. It's high available within an SLA and so on. It's easy to test and to debug. So the only thing you need is the portal to play and verify. And it's fast time to value. That's that slide again that I started 5 hours up front. What I wanted to show here is the monitoring. So it has good monitoring graphs, like the number of events, the number of errors. You have good details, like if events don't get parsed and so on. So it's pretty good in the diagnostics as well. Now, what does it do on the architectural view? And this is much easier to understand, and there's much less details than the previous one. That might have been a little bit complex, but this is much easier, much more for an end user as well. So you have event inputs. Where do you get your events in your jobs? Event Hub is one of them, and that's the one that I'll be using most because it makes most sense. But also Azure blobs could be for logs and so on that are written to blob. So that's streaming inputs. You can also use reference data. So reference data, you should consider that as static data. The data that you could use to enrich things in your query. You could say, for example, the devices are sending data, but maybe you want to have, you have a list of the devices in your blob that says this device is, for example, located in, I don't know, Belgium, France, so that, and you want to do some measurements based on Belgium and France to your output. You can always argue, do we have to have that in the job here, or will we use that in our reference data later? It's up to you. At least Stream Analytics allows you to take reference data and join it with the stream of events. So you can have joins, as I said. You can filter. I only want to get, in this job, I'm only interested in the temperature readings. In the other job, I'm maybe interested in the readings and so on. Aggregations, so sum, averages, count, all these things. So grouping by. A lot of things you will recognize from SQL. Projections, and then windowing, that's one that I'll have a specific slide, but that's to group events based on a window of time. You can enrich with the reference and you can correlate. If your job listens on these events, the query will run, and if there's output, if it results, you can specify that the output has to be written to either SQL Azure, so to your database, or Azure DB, to Azure blobs, and I'll use that a lot in just debugging, and to Event Hub. So you can also think about, you have the big stream of events coming in, you have Stream Analytics that writes a few of events to another Event Hub that you have a worker listening on, for example, to take actions. Because that's what it's all about. In the end, you will take actions. You will say, oh, this device is heating too much. I will now instrument the fan, for example, in the field to start running, whatever, you know, make things up. Or you will take an action, you will maybe submit a business process into your integration layer that starts or make something, an appointment in the CRM system to call that customer and say, hey, your solar panel is maybe not functioning well anymore. So these things are definitely what you want to have. Of course, the obvious one is the dashboarding and the apps. You want to see, you know, all these things. I've seen demos on this where they were live on stage, like the temperature, and they were just blowing, so heating up that temperature, and you could see a real-time dashboard. You know, you could see the spike like 1 second later. I believe actually that last week there was a nice video, 6 minutes video, where someone did a demo from Microsoft online with all of that. So Event Hub, Stream Analytics, a device with temperature, and Power BI on the back. Very simple to understand as well, so might be worth to have a look at that. Make sense so far? Okay. What I'll do is I'll try to set up streaming analytics in the first job. So again, you go to the portal, old one. By the way, by default, Stream Analytics is not enabled for your subscription. You have to register because it's a preview feature. So if you want to do that, account.azure.com for it, and you can register for the preview. It typically takes less than a few minutes or something before you get approved, at least when I did it. And then you have to search for one of the many icons. Is this one? I believe it's a nice icon. So the stream that goes into the analytics wheel. And what you can see, so it's indeed preview. You can create a lot of jobs. So the first thing that I will create, I'll have to delete some. Oh, they are stopped, so it's not a problem. One of the things that I want to say already, you see 6 tests here. All of them are listening on the same Event Hub. it was just to do a quick test. So you can have one job listening on, you can have 5 jobs listening on the same stream on event hubs. So if you would have 6 jobs, the 6th one won't start. So you can only have 5 receivers per event hub consumer group. Again, think back of the previous session. What you will do, and it's not exposed through the portal, but already in a PowerShell. So getting back to what I said, at this moment, you can already listen on specific consumer groups. So you will be able to say my event, this job. So you will have the ability to have 100 jobs, 20 consumer groups, 5 receivers per consumer group, to have 100 jobs per stream. So that should be enough, I guess. Now, what I will do, I'll create a new Stream Analytics, quick create. I'll give it a name. Think about the credits again. Western Europe. Now, what's important? If you create a job, you link it with a region, and for every region, you will have a monitoring account. So that monitoring account keeps track of all the logs. So that's bound with the region, not with your job. Yeah? So you see, I already had one, so he automatically mapped it with the one that I had. Click and create here. It doesn't take a long time. Unless if you do a live demo, then it always takes a little bit longer. So if I click there, I will be able to specify inputs, the query, and the outputs. Yeah? There we go. So you have your dashboarding, you have the monitoring, but the real development, if you can call it development, starts here. You start with input. Input can be of a type. That's where you have the stream of event hubs and blobs, or reference data. For example, a CSV file. I'm not listening on blob here, but on event hubs. And then I can very easily say, that was solar panels, I guess. Solar panel stream, for example. So this is just the alias. This is just the name that I will give for that stream. It doesn't have to be the same as the event hub. Then I will say, use an event hub from my current subscription. It's much easier. You can browse. If you want, you can read on other subscriptions. And I go to my development one. You see he's loading the event hubs, and he finds this one. Okay. What we will be able to do in one of the next releases to this portal is also select the consumer group. Now, if you use the portal, he takes the default consumer group. That's important. Yep. You can also specify the policy name. So which key do you use? He needs managed rights. I don't know why, but he needs managed rights. Anyway, you control it yourself, so it should be fine. Now, what you specify here, that's how will the events on this event hub be serialized. You have CSV. Let's go to the control 4. The tricky one. You have CSV, JSON, and Avro. Who knows Avro? You should explain me afterwards. I don't know. Is this like binary or? It's a binary JSON. BSON, compressed BSON or something. Yeah. Okay. So thanks for the input. So I clicked, yeah, right, the Dutch TV channel. I clicked escape by accident, so solar stream. Let's copy this one. Let's go back to my event hub. Okay, so remember in my demo, I used JSON. Okay? So that's what you will use mostly if you use event hubs and .NET, but you could use CSV as well. I'm clicking OK here, and I have my input. If I want, I will be able to create an extra input, another stream or another reference data, yeah, to make joins with. Okay. He also tests always. Even if you know that it's right, it always takes some time to test. Now, what you then do, you specify your select star from this. That's what I will do. That's the only thing I'll do here, just to show you how things work. This is the most simple query you can have. That's probably the first query that you wrote in SQL. Select star from your table. In this case, it's select star from stream. What I'll then do, I'll create an output. Input through stream. I do my query. All the events will now be written to the output that I specify. I can choose blob, event hub, or SQL database, directly to a SQL database. So it's definitely cheaper to have a stream analytics job than to write your own worker role that reads events from event hubs and pumps them into SQL Azure. This is out of the box with monitoring, and it's at a few euros per month. So let's write to blob. To my current thing here, and let's take my development storage account. You can then specify the blob container and the file name prefix. So the blob output, the blob will be outputted in a subfolder here. So let's create it in test, file name prefix. Voila. What you then do, you specify the serialization format. So let's use JSON again. But I could use CSV because then you have very easy overview as well. But let's use this one. So JSON, because I will be able to use it in my tests later on. Again, he's testing the connection, so you have to be a little patient. That's why the time to value could be even better. What I'm also missing, it would have been nice to just create a second output. So that blob writes to blob for debugging and to SQL for my dashboard, for example. Now I have to duplicate jobs, and it costs me twice because you pay per compute of the job. They are, I think it's on user voice. They are considering it for a feature in the future. So nothing sure of that. I can also scale. So this is comparable with what we've learned with the throughput units of event hubs. You can also scale streaming units. But again, it really depends on the number of messages. So each streaming unit, and that's depicted here, corresponds to roughly 1 megabyte per second of throughput. So you could say that if you have 4 throughput units on event hubs, you might have 4 streaming units. So it's pretty similar there. And you can also configure some things like out of order posts. They can drop messages, or they can adjust the actions with a tolerance window. That's if you want to have order by and things like that. And you also have a locale that you can select from English US. So this is probably for daytime parsing and so on, but that's the only thing they have at this point. Okay? I will start this job. You can also schedule it to start. And what I've understood from a discussion, but I haven't tried, is that you also could set the time in the past. Think about that event hubs where you have the checkpointing. So what is the case now? If I'm sending data to an event hub and I have my job running, they output, but then I say I want to change my job. So while he's running, you cannot change the query. So if I want to change the query, I would have to stop my query, but you're just getting data. If I then say start 5 minutes later, the 5 minutes time interval that my job was not running, they are lost. Yeah. So what it seems that if I would have set the start time to 5 minutes earlier, he would checkpoint on the event hubs. I haven't tried it. That's based on discussion I had yesterday. Yeah. Still, to make sure that the time is really the same as the last time won't be easy. So you might have to look into duplicates in your backend processing, in your Bob or SQL or something. That's something to keep in mind. Starting can take a while, several minutes. Any questions so far? No, because I'm finished, I think. Questions already? So the job succeeded. What I will do, I will use this one again. So I'm sending data, 3 senders to that event hub. Voila. And if I now go to the storage account, I believe it was in tests. Here I have a JSON file that gets created. So the last, it's 7:30 almost. The last 8:30. It's a UTC time, this one. So you can see that this file gets written. So all the events are now streamed directly to this JSON file. Yeah. Let's stop this one. What's also important, while the job is running, and Christophe is smiling, while it's running, you should not, you could say, oh, I tested, I will verify, so I could just say open here. While the job is running, you cannot, or you should not delete the file. You can delete the file, but the job, and you would expect that the job would create a new file. That's not the case. And so that's important. And you have to look into the logs to see that so if you want to do that, you have to stop and start again. So it would have been good that they somewhat lock or block the file, or at least created the file again. I believe it's per hour. Not sure. Okay. To be honest, I'm not sure. So, do you know? I know that one of the things that they are looking into is also that you can specify this name on Blob, that you can probably have more of these details. So they're looking into that. Yeah. That's what I said, that it would be good to log that one. Did I open it? Oh, Visual Studio. But what you can see, this is my JSON file. And by the way, it's an array, so they never close it because it's like opening still. It keeps open, so they get panned. So you always have to close that one. Yes. But what you can see the various. If you take this one here, you can see the field ID, grid IDs, all the properties that I had, and you also see the event processed time, the partition ID, and the queue time. So these are 3 system properties that get added by event hubs into your select star, right? So that's the basic thing you can start with. Let's do Control Z. And I will save this one. Why? Because I will show you how you can test full file name to here. If you now want to do more complex queries, so first of all, you have to stop. So you can then start writing more complex queries. And what you will see, I'm able to test my query without starting my job and doing all these things. So if I do a test here, he automatically detects what are the inputs that I need. I'll copy my JSON file, the one that I just downloaded, and that I showed in Notepad. And you can see that I'm able to test that query. Yeah, I believe that my query is stopped already, so I can say select, I don't know, some current from Solar Stream. So you have good, how do you call it, squiggles or something, you know, let's not do the sum then. Current device ID, it could be well the case. This should be right, no? Or is current the keyword? Who has that sometimes, that the opening bracket doesn't work? Group by panel ID. And I probably also have to do tumbling window. And second 5. That's what I'll be getting back. Because I'm doing an aggregate function, sum or average, I typically have to group by. I also have an issue here, device ID, it should be. So this is all very similar to what you know from SQL. So this seems to be good. I will test it. Let's see if you can just do rerun. You can see the sum group by a device ID. Every device ID was different because it's a unique ID. But you see, I have more concrete samples, but that's the way you can easily test your queries. Okay, this was very straightforward to start. I'll talk about some more details now. So you have the count, minimum, maximum, average, sum, all the things you know. You can cast. What's important? You only have a limited set of types. So booleans are not there, or bits. So it's only bigint, float, and varchar max, and datetime. That's the only ones you have. There might be others coming. What's important to know is that if you would, in your JSON, and that's an issue I had in the past, if you would have a bit boolean, for example, in the previous version, they were throwing a casting error. Yeah? Now they just cast it or make that value null. If it's a value, a data type that they don't support, they will make it a null. That's important to understand. Still, you can define your own data structure on top. You will see that in a query later on. You have datetime functions. So if you want to group by, for example, month and so on, you can use these things. So date diff, date add, that's pretty interesting. Like, what was it yesterday and so on. String functions, if you need that. So that's all possible there. One of the important things to get is the windowing. So you have the tumbling window. That's grouping by a time period. So even if you have 3 events or 1 event or whatever, it doesn't matter. You timestamp, for example, per 5 minutes. So if you say group, like the query that I did, select average of that sum by tumbling window of 5 minutes, they will wait until they have that window of 5 minutes. They will put the average and make an output. So that's the tumbling window, and they start again with a new window every time on 5 minutes. That's the most simple one, and the one that you probably will use mostly, at least in your demos and trials. You also have a hopping window, where you have overlapping things, and you can specify that overlap yourself. So you could say, my window will be 4, and I have an overlap of 3, okay? So that you advance. You can call that. That's probably in order to have more trends to, if for example, something would be stopped here in that interval, that you don't get a certain peak. So to more flatten out these extremes. And you have a sliding window. Yeah, sorry, I copied these from the websites, and in the sliding window there was no thingy. That was 5 minutes before my presentation, so you should consider it as they re-evaluate constantly the windowing. So it's like a very sliding window. As soon as an event advances, the window moves. That's a bit how you can look into that. Now, I will show a little bit more on the queries. And for that, what I used is traffic management or speeding. So who came from Kortrijk region to here? Okay, who came from Brussels region over the E40? So all of you have been scanned, at least your cars have been scanned with the traffic control. So I hope you know that. So they scan the license plate at position 1, and they scan the license plate at position 2. Yeah. This is a perfect example for stream analytics and complex event processing. So they scan it at event 1, and they don't know how fast you're driving. They just know car 1 was at 950 at this pace, yeah? And they scan it again some point later. These two events don't contain any information except that you were there at that time. The value would be how fast you were driving over that that distance between those two cameras. The only way to calculate that is to measure the events grouped by your license plate and so on. So that's the demo that I wanted to do. So I will generate speeding tickets if you create too fast. I will also publish the average speed to detect traffic jams. So if the average speed, you have to take it over a period of time. If you see the speed is decreasing, you see it reflected here. And also traffic management for suspected cars. Imagine that there's a criminal and you have a reference data of license plates. You want to detect that criminal and send out an event. That's the other thing. What's important, all of this is on the exact same event stream. Yeah? And that's what I'll show in my demo here. I created a UI, a very nice one, in WinForms. That's the best I can. Sorry, guys. Now, what it does, I will specify that the distance between the cameras is 2 kilometers. I will be able to simulate a number of cars per minute. So I think up to 500 or something. What I also do, just to test a little bit more of the queries, I don't want to wait 5 minutes. So I simulate the time faster, like 1 minute will, in this case, only take 15 minutes. So one simulated minute would only take 15 minutes. That's just to play with it. It's like a multiplier. No? One simulated minute will in reality take 15 seconds. Make sense? 15 seconds. You all know what I mean. I'm sure of that. What I also specify is like the threshold, because I generate random cars, the threshold of the slowest car, the fastest car, and the speed limit in that traject. Make sense? So what I will do, I will generate 61 cars. I'll make 9% of them speeding, and let's simulate a little bit faster, like 7 times. I'm driving, so they wait a little bit because they want to start driving separately. If you have a look at here, you see how fast they... Sorry. How it will work. For the people at home, a very nice joke. It was a speeding camera you saw. Anyway, you see, this is the license plate at camera 1, and it was the car is scheduled to drive at 113 per hour. That's the thing there. So you see, cars are just being sent. I don't see a lot of cars speeding, however. There was a 137. So these events are being sent to the event hub, to my traffic event hub. Yeah. So while that is being done, I will go first of all to the to one of the other jobs. Yes, the start is one. The traffic jam. So the input, as you can imagine, is my event hub query stream. I'll already start the job now. I could have tested with the custom time, but anyway. And this is my query. I believe I can make this larger. No? Strange. So first of all, what I do here, and that's something that I talked about with that data, the data types. Imagine that I would have a bit here. I could declare that bit in my stream. Actually, I'm declaring what the stream looks like, what my event stream looks like. So I'm saying the only fields you have to work with is the event time from my stream, the license plate, the make, so the brand of the car, and the color. These are published. That's the events I will work with. Imagine that I have a bit like driving too fast. I could mark that as an envar and as an varchar. It would normally be converted. That's just definition. The next thing I do is start by another projection. Sorry that this window is a little bit small. I thought it could be bigger, but select license plate, and then the minimum of the event time as first event, the maximum as the second event, the count, which is actually not needed, then from camera events, so from my input alias. And this is very important. If I don't put timestamp by event time, it would timestamp by the system time of that job. And then my multiplier or divider, the 15:1. The tumbling window that I have here would then be said, okay, even if I'm sending 5 times more events with separate event times, that would not matter. So if I say timestamp by event time, that will define how the tumbling windows will go. So the tumbling windows will go much faster in reality. If I would have a 5 times faster multiplier, a tumbling window of 5 minutes on this one would physically result in 2:1. Does that make sense? So you timestamp on a field instead of the timestamp of the date. I group by license plate and so on. Getting a little bit more. And I also say having count because I only want to take the events that occurred twice. They had to be twice at the same camera. Yes, but you can make it larger if the job is not running. Then you have the larger window. You can also write it in Notepad and copy it. But no, that's the only thing. You have IntelliSense, you saw that, but I cannot edit it. That's why I use the browser. But it's larger if you are in edit mode. So what I do here, the window time, so this is the system time. I do an average in seconds between the first and the last event. So that's what I define in the subquery, you could say, as I think average duration. So there I just specify the duration in seconds that the average car is running based on that tumbling window. Yeah. That average will be outputted to, in this case, a blob storage. But let's go and have a look. By the way, I will start decreasing the value, and I shouldn't put it 0 because I would have a divide by 0. I didn't catch that exception yet. But you will see that my cars that get sent will all be in that range for the camera 1 events in a few moments. Okay, so the cars will be slowing down. What you also should see is that the events will be slowing down because I only have so many cars per minute. That's why. Going back here to my storage thing. Speeding ticket, I think this is traffic jam. Last modified date. Yes. So I will open this one, and it's a CSV. It's tumbling window of 5 minutes, so it won't have a lot of records yet. And why does the CSV never open the way you want it? Because it's a CSV, exactly. So I can see the output of my query here. Exactly the system times. So every 5 minutes, I have it. I could have actually added the count to my output, how many cars were there in that window. You can see the average duration. So I could perfectly also say the number of BMWs, the number of Volvos, aggregates, counts, all of that is possible. So don't save it. Let's see if we have a refresh. Not yet. So after a certain time, you will see that the average will decrease. I'm just outputting this to CSV. Just let your imagination go. Output it to your event hub and have your API exposed to Verkeerscentrum, for example, whatever. Have your thing outputted to your database, and you can have a graph of the traffic speed during the day. It's just up to you, right? This is what I want to show. This is the intelligence you can write on that query. The output is all yours. Is that a question, or just stretching a little bit, which is perfectly fine for me? So you should be able to see that the data is slowing down. The next thing I want to do is showing you reference data. So I have the suspected scenario where you have a criminal marked car, and this car is driven by a criminal. And what you will see in my inputs, I will have two. I have my stream, the exact same stream that I'm sending to, and I have reference data. Reference data is just like this. You reference it to your blob container. You specify a file, JSON or CSV, or probably Avro as well. So, so you can specify. They cache it. What I was hoping is that I could add a suspected car to the reference data, and I could have the cache expire or something. That's not foreseen yet. So the only way to do that is stop-start job. Yeah. It's also something that they are considering. So the only thing I did here, if you would see that CSV, I think it's here. So the license plate, the suspected type, whatever, and license plate. If you then look at the query, what you can see I'm having that create table again. And the only thing I'm doing here, I'm doing an inner join. Again, just like you know with SQL. So this is my stream, and I'm joining it with my reference data. I'm joining it on the license plate. So if an event arrives in my stream, I will join it. I didn't make any complex logic, like there will be two events outputted for the same car if the car travels on two cameras. So I could have more intelligence there. One of the things I think I could cheat maybe with the algorithm, if I would go if I know that I was speeding and I go very fast again back to the first camera and slow down, I might cheat the system maybe because of my query logic. But that's all to be, that's unit testing later on. So the only thing I do here, if I'm matching with that reference data, I believe in the output window. So for that I have, because I generate my cars randomly, I have my suspected car event. So you can see I will just send it here. A gray Volvo of Belgium with that license plate, the same one as in my output there, and he's driving at 140. Just sending it. It's a real criminal because remember it's a traffic jam at this point, so it has to be an insane guy driving at that speed. So the event, backstroke, yeah. The event was sent, and I hope. Oh, my job is not started, eh? So my job was not started. So that's the reference data. Okay, I'll try to come back. This is the graphs you can see, but there's no events yet. But that's where you could see, if I would go to the next, the traffic jam maybe. That's where you see some real-time states, like the number of events, the number of failures, and so on. That's what you see on the left there. I don't think you can go smaller than 1 hour. So now, the last one is more of an end-to-end example where I want to generate speeding tickets. So the speeding tickets job is this one. And I will start it already. So it also just reads on that same queue, event hub. So the same stream, camera event. If you then look at the query, again, the exact same logic. This is the same table that I've shown before. So select license plate, event count, first, last event. I'm grouping by this tumbling window of 5 minutes. So this is probably something I have to change, because if your first event would be in tumbling window 1 and your second camera event would be in tumbling window 2, I don't think that will work. So if I would have more time, this would probably be a sliding window or something, or a hopping window that I have 2 windows or something. That's probably a catch there. So that's, I define speed measurement, and then I do a select here. So I'm outputting the license plate, the duration, so the difference in seconds between first and last event, the make and the color. This is smaller than 60. So if you 2,000 meters would drive less than 60 seconds for that distance, you're driving more than 120 per hour, and that would result in a fine, in a ticket. Yeah. So I'm outputting it to SQL's database, and let's already increase the speed again. Is my job running? Yes, my job is running. So let's go to that database there. If I do a refresh here, what I should see is that the speeding data is outputted here. So the event time, the license plate, the duration, the make, and so on, they are all outputted to that database. So as soon as speeding cars will be processed by that job, again, it's a tumbling window of 5 minutes, so it could take some time. They will end up here. Yeah, I could build a nice public website with that so that you could look up your fines. That's probably not privacy okay. So what I did for that instead, we used our processing engine integration cloud, where, for example, we listen on that database. I'm probably logged out because it's an open session. I'm listening on that database for new events to arrive. If a new event arrives, Rijksregister, the citizen web server, let's say, I give the license plate and I get back the information, the name and address and so on of the person there. So let's get back here, traffic control. So what you could see, and there are new speeding tickets entering already. So you could see at 8:50 something, there was a white Toyota with that license plate at that speed driving, right? We don't publish any citizen details, also because it is a hard-coded service and it's always the same guy so far. At least I'm honest. So that's a speeding ticket. Here I have a workflow. That workflow calls a web request, a PDF. That PDF is a fine that you would get into your mail. It's also signed by the procureur, probably. And what we do, instead of sending it to the mail, we are writing it here, as you can see, to the FTP. And if I'm opening it, what we should be able to see, if my computer picks up, is a very nice fine, the one that you don't want to get into your box. So where we have the license plate, you see it's this guy again. So license plate, all that data is coming as an output from that job. The speeding is from there and so on. So that's the one that we have created. Thanks, Philippe, also for the nice PDF generation. And it was signed, okay? Just to show that Stream Analytics is there to make your intelligent data or to make the intelligence decisions. The output can be virtually to anything you want. If you want to have your custom code reading on that, you can typically have your event hub as an output, and you can write a worker role to process data. Yeah. So for that, I have one last demo normally, because I know that it's getting late. And this is a very nice demo again, one that I didn't create myself. It's one that will probably be, become public later on by Microsoft. So what they do, they have worker roles, but in this case I will just use the console applications. They are having some keywords to search for, so Microsoft, so your brand typically. I also entered Pancake Day, because today seems to be worldwide trending. Pancake Day was new for me, because I want to get quite some tweets. So this one is listening here with the Twitter streaming API for all the tweets that match one of those keywords. Then he is publishing that to Event Hub again, lots of data. So there can be tens of machines, right? No problem. They publish it there. Then we have Stream Analytics to just archive all the tweets to a blob storage. So select star, and everything is written to blob storage. This is something that I haven't set up, HD Insights, but if you want on that archive, run your cluster jobs to get intelligence about your brand and the way that social media is talking about that. That's a perfect example. You have one type of data coming in, and you archive it already. And this can be something that you schedule. What I'm also doing, I have two other jobs. This will aggregate the tweets by topic. So he will say Pancake Day, for example. That's the average topic. He outputs it to the Event Hub. And on that Event Hub, I have a worker role that just listens for all these tweets. Again, this is a console application in my demo. And here, all these events that are outputted are pushed to a client, a nice dashboard, using SignalR. So we know SignalR, but that's to get interactive web front-end things. So that's what we have there. This one, but I'm searching here. This worker role is also calling Sentiment 140. That's like an online service where you can give a tweet, and they will give you back the guess, maybe a negative. Oh, we are on YouTube. I should be should be careful. It should be a negative sentiment. If I write Microsoft rules, it could be good. So you have neutral, good, and negative. What's also in the demo, but I won't show it, this is also calling machine learning API to get that sentiment. So we have a trained model based on an R script. It's complex language. I don't know anything about it. I just took it. But it's like data scientist stuff. But it's also based on a dictionary, based on some measurements. It can predict that your tweet is good, neutral, or bad. That's machine learning, so that's a model you can train, and that model can then be exposed as a web service, as an API. And this workahole is also calling, and that's not on this picture, but that's calling that machine learning. Configure. It's here on the left, yeah. So you can choose either between sentiment or this one. It's a configurable thing in the web config. Yeah. So what we see, Stream Analytics, because that's what the talk is about, is used on the same type to archive everything, to aggregate tweets by topic, like the number of tweets, and to aggregate the tweets by sentiment or something, and to publish them out. So how do we get this to work? First of all, closing the previous demos. So I will just do an F5. So I assume that this demo, because they are also building something, it's in preview, but Power BI as a service will be coming, and you can subscribe, but it's a long list. One of the outputs, so we have Blob, SQL, and Event Hub. One of the other ones that will come up is Power BI. So where you will be able to publish directly Power BI thing. Power BI, that's like the chief monitoring thing. In Excel, you would be, and on the portal, you should see real-time charts coming from there. So that would be pretty out of the box. Anyway, this would be my real-time dashboard. Let's do an F5. So this one is opening in a Signal R hub, where the listener on that event hub is listening to and is publishing the data to this dashboard. So what we should see, at least that's what I hope, is tweets appearing here and the aggregated counts appearing there. So there we have the tweets already. So they are going through that job. That's why it took a bit of time. And they are then published by that consumer to there. Then we can see by topic, that's the aggregate by topic things. So that's, we can see that the average sentiment of Pancake Day is 8 on 10, where Microsoft is pretty neutral at this point based on the tweets. It's a 5 in 10. Yeah, I have some other topics. So if I could have added Azure and maybe see if you appreciate the sessions or not. But that's the way. That's just to give an example of how rich you can make your dashboarding and how real time you can do it. It's like real-time analytics. It's all stream based. And normally you should see this graph moving as well. But again, you get the picture, right? Does this make sense? Scenarios, so you have dashboarding, you have actions you can take, you can just have long-term storage, for example, for your HG Insight, for your machine learning, and so on. Okay? Then to end, I have some last tips and tricks. I think I stressed this already, but use the timestamp by instead of if you wouldn't add this, it would not look at your data, but just at the system time, where for you it's important that you look at your event time, even if your publisher was running a little bit behind. That's what's important. So timestamping by. Choose your windowing logic. As I said, probably my speeding job was not the right windowing thing. So think about your windowing logic good, because that can have an impact in your results. The consumer groups of Event Hub are not supported in this portal version. As you've seen, I could not select it. It will come. If you already need it today, you can use the PowerShell, because since, I believe, last week, it's part of the new PowerShell job there. And that's one specific for Christophe. Don't delete your blobs while your job is running, because otherwise you can wonder why your job is not outputting. So that's an important thing. Okay, with that, I'd like to thank you, but I'm open for questions. If you don't ask them now, don't hesitate to ask me afterwards. Any questions so far? Okay, thank you. Have a good evening.